Okay, so we've got the total force here. How do we determine its magnitude and its direction? For its magnitude, we need to know how big F1 is and F3 is. So to determine them, we use Coulomb's law twice. So if we want the force due to number 1, due to this charge here, we need to use Coulomb's law, but we'll do it for charge number 1. So it'd be this formula here, F equals 1 over 4 pi E0. Charge number 1 and charge number 2 over the distance between them squared. So if we use that formula, that gives us the force due to charge number 1. And for the force for charge number 3, we've got to use that formula again. It'll be 1 over 4 pi E0. Charge number 3 and 2, or 2 and 3, either way. But we need to use the correct charges there. And that will give us F number 1 and F number 3 if we use those two formulas. And usually the examiner might get you to do that first and determine the magnitude of the forces, and then they'll be used down here. So we can use those two to calculate the total force. Or conversely, a question might tell you the total force and we need to calculate one of the other forces. We can use Pythagoras to relate these two sides of this diagram to the total side. So that's how we can determine the magnitude of the force. To get its direction, in the rare case you might be asked for the direction, we would need to quote some kind of angle in this diagram here, like that angle there. We'd have to use trigonometry to determine that angle using either sine, cosine, or tangent. And we might use tan of the angle is equal to opposite over adjacent there, and use that to determine the angle. Now, there's one extra formula we can deal with, and that's one for the electric field strength due to a point charge. So I've got a charge here, and if I'm some distance away from that charge, we can ask the question, how strong is the electric field at that point? There's an equation that tells us that. This equation here, we just need to know the distance to that point from that charge and the value of the charge itself. There is no charge at this point yet here. We're just using this formula to tell us how strong is the electric field here that's coming from this charge. We may need to derive this formula, and there's a way we can do that. Is the definition of an electric field strength. If there was a charge there, the electric field at that point would be the force on that charge divided by how big that charge is. So I'm just calling Q star as whatever test charge might be there at that point. So we can use that formula combined with Coulomb's law, which should tell us the force between that pretend charge there and the big charge, charge big Q here. And that would be this formula here, Q and Q star over R squared, like that. And this here is equation number 1, and this here is equation number 2. I'm inserting number 2 into equation number 1. So I'm going 2, and it's getting put into number 1 there. And then when I do that, I'll get that the electric field strength is equal to 1 over 4 pi E0. Alright, there we go. 1 over 4 pi E0 Q star over R squared. So that's this equation here taking the place of F, and it's still being divided by Q star just like it is here. And then our Q stars there end up cancelling each other out. So this one here and this one here end up cancelling each other out, and then we're left with the equation that we want. The equation we want is this one here, and that's what we finish off with, just like it is up here. One thing we can do with that last equation is figure out the electric field at a point due to 2 other charges, not just one. And it's similar to how we figure out the force on one charge due to multiple other charges. So here we can use the equation E equals 1 over 4 pi E0 Q on R squared, and we end up using it twice, once for each of these charges, once for both of these charges here in relation to this point. So first off, what's the direction of the electric field coming from these charges? Well, what sign are they, positive or negative? So let's make this one here positive and this one here negative, like that. And then we'll have two electric fields that are going to interfere due to these two charges. We'll look at the electric field coming from charge number 1. Now, charge number 1 is negative. And we know that if we have negative charges, electric fields go inwards towards the negative charge. So that means that at this point, there is a vector representing the electric field. Here it is. And that's E, it's kind of an E, E from number 1. And it has to point towards number 1 because it's a negative charge. From the positive charge, though, electric fields point away from positive charges. So we'll have the electric field due to number 1 going downwards like that. Sorry, that's number 2. Electric field due to number 2 will go downwards like that, away from charge number 2. Then now we have our two electric field strengths, and we're going to add them together as a vector diagram, and that will give us what the total electric field strength is. So there's my vector diagram. Got E1 there first, and E2 added on the end like that. And then we finish off for our total electric field strength like this. So this vector here, its length and its direction, represents what the total electric field strength is at this point here. That's some distance away from the two charges. Once again, to find how big that is, we would have to know what E2 is and what E1 is, and you'd use this equation on both of these charges. So to figure it out for number 1, I would use this equation, I would use Q number 1 and R, the distance from number 1. So it would be the distance from, the distance from here to there. And if I wanted E number 2, I would use charge number 2 and the distance from number 2, so the distance from here to there. And that will give me my two values for E, E1 and E2. Pythagoras would give me how big ET is, and then once again, I would use trigonometry to find the direction. And I'll be quoting some kind of angle here, probably this one, so that I compare its direction to a horizontal direction there. And there we go. That brings us to the end of the video. Tune in next time, and thank you for watching.